Okay, we are live. I want to not look at this for a little bit. I want to not look at this for a little bit. Where's his latest paper? This one, right? Yeah. Review mode. We're going to go over this. The plan for right now, we're at least going to spend a little time looking at this, and then we're going to do some thinking about exploration. We introduce random, I'm going to just read this part of this out loud. We introduce random latent exploration, RLE, a simple yet effective exploration strategy in reinforcement learning. On average, RLE outperforms noise-based methods, which perturb the agent's actions, and bonus-based exploration, which rewards the agent for attempting novel behaviors. The core idea of RLE is to encourage the agent to explore different parts of the environment by pursuing randomly sampled goals in a latent space. RLE is as simple as noise-based methods, as it avoids complex bonus calculations, but retains the deep exploration benefits of bonus-based methods. Our experiments showed that RLE improves performance on average in both discrete, e.g. Atari, and continuous control tasks, Isaac Gem, enhancing exploration while remaining a simple and general plugin for existing RL algorithms. Project website and code here. Okay, so Atari and Isaac Gem, better than some for experiments, but we're not going to have total confidence on that. Let's find the method. First of all, I want to see their definition of exploration, because this usually papers get it wrong right here. As the reward may be delayed and not immediately presented to the agent may need to take many actions and visit a sequence of states without rewards before it receives any learning signal reward. As such, taking a greedy action A at each step that maximizes immediate reward does not necessarily lead to a high return. Okay, but nobody does that. Thus, RL algorithms require exploring states and actions that may lead to low immediate rewards, but could potentially end up with high return in the long run. We refer to this process as exploration throughout this paper. I don't like that definition at all. I think that's a useless definition. And the reason that that is a useless definition is because that doesn't tell you anything about the mechanism by which, well, it's almost a non-definition, right? We refer to this process as exploration. You refer to the process of, like, taking actions in general as exploration. Like saying, oh, you need to visit low value states to get to high value states, like, by what? I don't know. I guess what it means is it doesn't capture the human notion of exploration either, because it's like it's a definition that's completely mismatched with the human definition of exploration. So yeah, okay, here, my precise criticism about this now is that this is using a high-level, common sense human term, right? Human, like, human word that we use for stuff that we do, and then applying it to something that's completely at odds with that. So this definition of exploration does not match what we mean when we say exploration when we do it. So we'll see if the method is good, but right here, this definition like kind of prevents you already from doing anything. To be fair, this is done over, it's kind of, you're just trying to improve over previous action noise stuff, so maybe. The key challenge in noise-based exploration is their limited ability to generate diverse behaviors. Well, what's that mean? Although noise-based exploration changes the agent actions at each time step, in practice these perturbations are too local to deviate significantly from usual trajectories. Okay, now we're getting somewhere. As a result, the generated trajectories can appear similar to each other, limiting exploration to a narrow region of the environment. Primary technical challenging then is devising a method that ensures such diversity. So I see what they're trying to do. The framing of it is very murky, but I see what they're trying to do. This is reasonable. Randomized rewards. We have proposed enhancing trajectory of diversity by altering the agent's rewards, inspired by skill discovery methods that learn skills based on different reward functions that push the agents to visit different parts of the state space for different skills. Following a similar idea, in every training episode, we perturb the given task reward function by adding a randomized state-dependent reward function, and we train policies by maximizing the sum of randomized and task rewards. The key idea is that in every round of interaction, the agent is incentivized to visit areas of the state space with high randomized rewards, and if these random areas are diverse enough, we will get diverse behaviors in the environment during training, thus incentivizing exploration. However, since the random rewards are repeatedly resampled, and thus keep on changing during training to enable stable and effective learning, both policies and value functions must be aware of the specific random reward function in use. Otherwise, the changing reward functions will comprise a partially observable MDP. The framing of the paper makes no sense. We take inspiration from Universal Value Function Approximator, which trains networks based on varying goals. We adopt their approach by equating their goals with different reward functions, thus making the policy and value conditional on the sampled reward function. It's making the policy conditioned on the sampled reward function. This ensures that random rewards no longer appear to be noise to the policy. Your main questions are how to implement the randomized reward function, how to make the policy and value function conditional on it. Randomized reward functions. We design a practical approach to implement a randomized reward function using two principles. First, reward function must be dependent on the observation, otherwise rewards be random noise. Second, the policy and value function must be conditioned on the randomized reward function so that the reward function is fully observable to them. Efficiently implement this, and this doesn't say anything about the structure of the function either. Dot product of state feature, and a randomly chosen latent vector, where where phi is a feature extractor, just means it's probably the main network. Randomized rewards for each state are generated by sampling Z from a different distribution. A given distribution, PZ, and then setting rewards as f of S and Z. Even if f of S and Z is high as unreachable parts of the state space, agent simply does not collect rewards and moves on. Does not derail training as Z is resampled at the start of each trajectory. Yeah, this is bizarro. Latent condition policy and value networks. Recall that the policy and value function must be aware of the state and the random variable that factorizes the resampled reward function f. To achieve this, we augment the input to the policy and the value function with the latent factor z, resulting policy and value networks pi s and z and value pi of s and z. We train latent condition value network to approximate the expected sum of the original reward and the randomized rewards as below. So reward plus lambda times this noise. Latent. They don't have JE in here. What? They missed lambda. Okay, so this isn't exactly JE, so this is a mess. Latent vector sampling. To ensure the agent is exposed to a wide range of randomized reward functions, we randomize the latent vector Z, done by resampling at the start of each trajectory. Trajectory is rolled out under the same policy and latent vector. We randomize the latent vector Z, which is done by resampling at the start of each trajectory. Okay. That's annoying as hell to implement, but sure. Same policy. Sampling and distribution is discussed in section 4. As we train the policy condition on the randomly sampled latent Z that defines the randomized reward function, we term our method as randomized latent exploration, or random latent exploration. We outline the algorithm in algorithm 1 and present detailed version in algorithm 2 in the appendix. We compute, in line 6, we compute the randomized reward using the next state, since the next state reflects the effect of the agent's chosen action in state ST. This choice is common in prior works. It's also obnoxious as hell to implement that. The exploration bonus is a function of the newly reached state rather than the current state. Sample fresh latent vector, take action, receive reward. We compare RLE performance against the action noise exploration. We train using standard PPO. Compared to these baselines. And then they get this type of a thing. Hang on, what even is this? No reward free. Oh, so this is a worthless experiment. Because it's not getting any reward. So this PPO, this is worthless. Okay. I like how PPO is above R&D and NoisyNet. It's funny. Is it gemmed by... Yeah, they use CleanRL for this. They not cite CleanRL. Better have. PPO. Okay, so they say that this makes a big difference. So they did do some ablations here. So how much do I trust these experiments? There's no exclamation Discord command, but it's just discord.gg/puffer. And all the links are just on puffer.ai as well. What do we think of this method? It's like a similar to R&D method. It relies on hold on. See, the thing with all these noise-based methods is they rely on a random network producing some sort of like meaningful smooth distribution over different observations, right? That seems really, really stupid. I'm wondering if the what do we think of these as benchmarks? I mean, they kind of have decent benchmarks. It's better than the average RL paper. I will give them that for sure. With benchmarks. I could see it helping. I'm not happy with it, but I could see it helping. Maybe let's go to the appendix and see how they implemented this. How hard is this to put into PufferLib as a test, right? And how expensive is it? Compute feature f of st plus 1 equals and you compute random reward, receive reward. Reminds me of the paper that says adding random Gaussian noise to the output of the actor helps in continuous. That's a really stupid exploration method, though. That's like a really stupid exploration method. Like entropy should do that as well for you if that's all you're doing. A lot of these papers that propose stupid methods and still get results, the results are just better because they didn't bother tuning any parameters at all. So essentially, when you have a weak baseline, like if you have a really weak baseline and you put in some graduate student hours, anything will beat it. Like you could come up with an idea that makes absolutely no sense and tune it more than the baseline, it'll work better. Give it a snazzy name, and there you go. There's your oral. I tried it once with Impulse Wars and got weird results. Yeah. Well, I mean, this is dramatically better, at least, than most of the stuff I've seen in exploration. I'm not sure if I like it, but it is dramatically better. Seems similar to this paper. It's not going to let you link the paper, but if you put the name, I'll look it up. Have you moved on from P3O work? Is this is for something different? I'm going to come back to P3O, but I'm getting behind on other stuff, and the P3O is giving me a massive headache, so I will come back to that. Mm-hmm. Sorry. Sergey's group. Oh yeah, it's been a while. I remember this, but I don't remember what it is. Sample environment, sample action, sample skill. Z in P of Z. Sample action from skill. Sample one skill from fixed skill distribution. Sample environment or step environment, okay. Compute Q with discriminator. Set skill reward. Log reward equals log Q minus log PZ. Yo, to start, should I not worry about reducing road points? Load in about 10K. Yeah, to start, just load in the data. Just get something that like looks kind of like their original sim. Update policy. Update discriminator. Just got Jason on to see. Very nice. Good job. I've been just banging my head against algorithms and math, which is not what I usually do around here. But we're going through exploration papers. That sounds like a load of fun. Oh yeah, it's great. It's second only to chewing on broken glass. But we will figure some stuff out. Diversity is all you need. A lot of math, a lot of math. Interesting. I mean, this does look kind of cool. Yeah, I forgot about this paper. All right, maybe we just have something here. This seems better than the other one. Which is funny, this is like a much newer paper. This is like a brand new paper. Update policy to maximize RT. Oh, hang on. This doesn't include environment reward, does it? Okay, so we need the version that has environment reward, right? Well, you can just add the reward to it. Okay. The silly thing about this is that these are such easy tasks. Like the tasks that they call hard are tasks that I could just insta solve in PufferLib. That's the thing that's hard to know. Though I think, and they also only have control stuff. I mean, this is promising at least. So they sample skills from P. sample action from skill, step environment, compute some function with discriminator, set skill reward, Does it matter if you do it on ST or ST plus 1? I think it probably doesn't matter that much. It's dramatically easier to implement on ST. So what would this require then? It requires that you make this archive. You have some way of sampling on done. That's not that hard. You add a subnet. Yeah, you add some sort of subnet. I mean, that seems reasonable enough, right? Are there any follow-ups to this? Let's make a branch for this. Start on this. Oops. Probably should do this now. So you need an archive. Forgot that. Oh yeah, do we know the size of these things? I guess it's just gonna be n, right? Hidden size. Do this. Now, sample action from skill. You need an additional thing. Where'd it go? What's the way that we do this? I think I have a function that does this in PufferLib sweep, don't I? Samples 2 times movement indices. Yeah, something. It's probably something like this. For these duns. Yes. All right, so this should sample new skills on done. Okay. And then we have actions, log probs, state, compute queue, with discriminator. So that'll be experience.skill archive. The indexing is wrong here. The ID of done mask, yeah. There we go. That was almost a bad indexing bug. So now we need to sample. We sample the skill vectors here. We have these already. They're constant for the whole trajectories. And we need, we're not going to use st plus 1. We're just going to use st because it's easier, which is just O, right? I'm trying to think if it's easy to, B is hidden.detach. Where's hidden? It's P3O. Oh, you do get hidden back, right? Perfect. I already did this for E3B. So I'm just going to say that this is going to be self.policy, or is it data.policy, whatever, policy dot discriminator. I'm going to take hidden and Z, like this. And then R plus equal you still need to do config times, was it? Forge.log. Log of P of Z. Uh-oh, they have a sampling distribution. It's not just uniform. Well, I can just do it like this for now, right? And then we'll do to check sampling distribution. Yeah. So that's pretty much it, except for this bit. And we don't have use E3B anywhere here. So I have to add it. Use, what is this? AYN equal false. We do if use time. And this almost already had what I wanted in mind, except it's 2 times hidden size to hidden size. Relu and then hidden size 1. And do I want to throw a TNH on this? I might want to throw or a sigmoid on it. Welcome back, thank you. We're working on something a little different now to give me a break from hard things. We went through this paper from Polkett's group. I had some misgivings on this. I got suggested this paper, which I don't know how I forgot about this because I think that this was a big thing when I was at OpenAI. This is 2018 or 2019? Yeah, 2018. Then I'm pretty sure that we saw this while I was at OpenAI and it was kind of cool. But I completely forgot about it until I was just reminded. So we're going to try this. And it seems like it should be like relatively fast, relatively low overhead as well. And then all we need to do is update discriminator with SGD. How do they update the discriminator? Uh-oh. What's the discriminator loss? Do they have this loss somewhere? Yeah, this is a large paper, lots of experiments, very tired grad students. Where is this thing though? We need the loss for the discriminator to be able to finish the implementation. Update discriminator. We maximize. What on earth is this? Hang on. We construct our objective. S and A are random variables for states and actions. Z is sampled from P of Z as a latent variable. We condition our policy. we refer to the policy condition on a fixed Z as a skill. I and H refer to mutual information and Shannon entropy. They have code for this. They've got some bullshit notation here. Videos here. Oh, do they not have code for this? I just need to know what the I just need to know what the objective is. On GitHub. Maybe there's a loss in here. Okay, here's your discriminator. Discriminator loss. Cross entropy loss with logits and ZS. Wait, logits is dot split. Self-discriminator. And then you just do cross entropy loss of the discriminator logits with ZS, which is batch.z. Let's see if we can figure this out. Oh, you just literally, wait. Is this thing trying to produce its own skills? I'm confused. Cross entropy loss. Does this make sense? Policy loss. Props minus Q. Okay. Torch dot split. States and skills. Wait, PZ. Wait, huh? Oh, yeah, this is just the forward pass bit of it, right? They've done some weird stuff. But then the actual loss is discriminator, and then ZS, which is just the original sampled skills, right? Where's ZS? Unpack of batch, okay. So we just have to store the skill vector used at each step. I'm gonna paste this into Oops. I just want to know if this implementation is likely to be correct. Alright, that's not going to tell me much. Let's hope that this is correct for now. And let's just implement this as is. Because otherwise I'm going to start getting bored. We need to include then an additional thing in the experience buffer, right? Let me not cover the chat so badly. Where is it? Okay, DIA whatever batch. And then when we do store, there. That's all. Now we have this stored. Of course, we have to add this to the eval loop. And we're almost ready to test this thing. Or at least to make sure it runs. Let's do lf data.use. Let's do this. And it's not actually going to use this CUDA kernel. It'll cache it so it won't take long the next time. Okay, no DIA whatever archive. DIA AR archive. Just spelled it wrong everywhere, right? Oh no. We don't really care if we make a little bit of a mess in the process of doing this because, you know, these changes don't get kept unless they actually work broadly. LSTM wrapper has no object, DIA, well, whatever, discriminator, okay. OSS adder. Oop. DIA. What do we call it here? Maybe it's not getting passed? Yeah, it's not getting passed. Sequential.forward takes 2 args, but 3 were given. Okay. Oh, that's easy. It's just going to be a dot, right? One hidden. Let me just think about how we do this. We can kind of just do hidden this. So something super basic like that. Uh-oh. And you have to pass both of these, don't you? Hidden Z, no? Cool. So this is fine. Okay, now we get up to here. We get some indices, right? Not all the indices, but a lot of indices. Oh wait, we don't need, hang on. Experience dot I don't know why I can't spell archive. Okay, 0. Experience has no attribute. Okay, cool. So this actually does give us try this. This should now give us a sampling of new skills. If I can actually spell. Now, every so often I wonder about coding, doing all my coding without an LSP. And then I go, nah, it's probably fine. Well, it runs. Here's the restroom. I'll be back in a minute. You can see if that does anything. Okay. Well, that's a pleasant surprise. For once, an algorithm doesn't completely crash learning, assuming it's actually getting used. Let me see. Well, we're not optimizing the loss yet, though. We need to add the loss in. We need to add this to the batcher now, don't we? Will you take on games like Dota or StarCraft 2? Nope. And not because of the RL component, but because they run too slow for me to do so at a reasonable scale. You need like minimum thousands or tens of thousands of CPU cores just to run the games fast enough to keep up. We will take on relatively complex problems, though, that run faster. So the whole idea here, right, why I'm doing this, um, I'm pretty darn good at making progress very quickly on things when I can keep things lean and keep things moving fast. I don't want to get like bogged down by like a really capital intensive, heavy weight ends, this sort of stuff. That's like where things just RL progress grinds to a halt. So the way I'm doing stuff now in Puffer, it's pretty easy for me to just be making progress very, very quickly. Um, so anything like that where we're working with something heavier, we'll do that in the context of like, assisting with a company that's trying to do something like that for their own purposes. But for our core stuff, we're focused on keeping things really lean and really fast. That said, we now do have multi GPU, so if there's hardware, you can run stuff faster. We have people using Puffer now on multi-node too. Right. I can actually do this at the bottom, right? So we can just do z variance dot. I don't think this is the right one. DIAYN batch, right? Yeah. This one does need, is it B indices or B flat? It's B flat. Okay. Uh-oh. I need to replay the discriminator, don't I? That's annoying. Yeah, I do. That's really annoying. Policy forward train, and I don't get hidden, do I? I don't get the hidden state back from this. else. Okay, so now I have hidden. Hidden, and I have Z. So we'll see what shape that is. Oh, lovely. It's already in the right shape somehow. And I do have an LSTM. Did I return the right thing? Oh yeah, because it's already reshaped correctly for me. That's nice. I think it's hidden in Z. It's data.policy. Policy. And it's just cross entropy of Q and Z, isn't it? Almost done. We almost have this whole thing implemented. So this wasn't that bad. Multi-target not supported. Uh-oh. Maybe I spoke too soon, let me see. What did they do here? Criterion is cross entropy loss, right? Discriminator and the skills. Wait, out features equals n skills. Maybe I'm misunderstanding this. Relu, hidden Q. But then it goes to n skills. Oh, so it's trying to figure out what skill this goes to, I guess. But then, how's the reward defined? I think I have the math a little wrong here. Reward is log Q minus log P of Z. Does anybody know what this means? Update skill. We find the implementation of this. PZ self.pz. Okay. And where do they get the discriminator the first time? They get it here. PZ equals pz.gather. So they take log softmax of the logits dot gather zs plus log pz plus 1e6. So does anybody understand how the hell this works? I don't. You get log ZNS. Okay, log softmax I understand. Log softmax of logits is fine. But then you index it with... So you're just taking the index of whichever one this corresponds to. I can do that. You need the indices then, right? You need the indices. Yeah, you need the indices. So we'll do that. Oh, I had the wrong G-type in here anyways, so this is better. Skills. Archive. The archive is fine. Self.diayn skills equals rand int batch size. And is this batch size? I don't think this is batch size. I think I need this to be num_ems, which is the same as the LSTM state. So it's LSTM total agents. Let's get this. All right, I thought this would be easy. There's a slight holdup though. Still not that bad. Do you think it'll matter at all if I drop coordinate values of the positions from float 64 to 32? No, not at all. Just don't drop them to float 16. All right. This is roughly what it needs to be. We need to just fix whatever I made, whatever errors I've made. Hey, was looking at setup, not try to building box 2D without CMake. They don't distribute pre-built archives. Lovely. I guess you'll have to make the PR with CMake then. Build archives. You could do that as well. That would also work. Do you see how the argument though for CMake is literally like it's because everything else is hooked into CMake? It's the cancer argument, right? It's like because there's some cancer over there, you need cancer here. Moving to CMake will be a large task. Sounds good. Let's like not do it for now then. Uh-oh, what happened here? Oh, wrong size. Easier to work with and maintain. See, I'm not sure it is the problem. Need to make a big PR for box 2D fork. Yeah, you can PR whatever the box, that's fine. That's totally fine. What is reward on CPU? Somebody want to explain that to me? I don't think, is this how it works? Drive me crazy with this. Gather -1 and then the index, right? Maybe it's this. Oh, I think take is 1D indexing. Yeah, that's wrong. Input dim index. How does that make sense? Driving me freaking crazy. and they ask, all right. Okay, we get down to here. I think it works. Uh, that's weird. This should work. How is this triggering? How the hell is this triggering that? Probability tensor contains, okay, imps or nans. Cool. Lovely. Let me see. So log softmax. Maybe it's, I think I did this one wrong. Yeah, I did. Hold on. This is log softmax. Softmax q dot gather. Okay. Log props dot detach. Dot tensor equals -1. There we go. Cool. So this actually trains now. We can now get the discriminator loss as well, right? Do that. And then is it immediately optimized to 0 or something? Yeah, so this is like immediately optimized. See? So they say, hit the discriminator, you log softmax, torch.log. Okay, that's easy enough. Where is it? Torch.gather. PZ is pz.gather. Wait. PZ. Oh. So that's this right here. This is what they're calling PZ. PZ. No, it's not. Ah. Drive me nuts. And then they don't update this anywhere, right? One over n skills. So that's literally all it is. So they're doing this fancy ass thing. Plus torch.log. Data dot. Fine. Okay, so this PZ is just done. And then you take log softmax of the logits along index, right? And the discriminator is just Q. It's just this, fine. So table, still 0 loss. Then where's the other loss? Where's the other loss? So you get logits and then ZS. Oh, negative? Hang on. Discriminator loss dot backward. Wait, what? Hang on. Why is it negative? Just logging, okay. So this does not train, and this loss is immediately 0. Dim equal -1. Hmm. Params? Where params come from? Get params? Number of skills, reward scale. It's weird. Discriminator opt. Discriminator loss dot backward. It's cross entropy. So you're predicting what Z it came from. Okay, so that's weird, right? Because this says you're perfectly predicting which one it came from. Let's thing. Why is it like that? Oh, no, that makes sense actually. Because it's per trajectory, fine. Doesn't look optimized to me. Does that look optimized to you? It doesn't look optimized to me at all. Oh, no, it is learning this. Okay, so this thing is correctly predicting where it came from then, perfectly. Really though, in one update it's doing that? Your reward is... Why has everything gotta be so freaking complicated, man? Why all these papers have to be this way? This should be simple. It's just, like, very confusingly written. Okay, you take log softmax, right? And then the reward, max entropy loss. States, states, skills. This thing outputs logits. Torch.split next states. And states and skills. I don't understand this split. Oh wait, maybe I'm not supposed to give it. Maybe I'm not supposed to give it the skill vector? I'm confused. Compute Q Z given ST. Hang on, maybe I've totally messed this up. PZ. Oh, there just is no noise vector at all. But wait, how do you do condition on Z here? Wait, how do you condition on Z then? Action has to be conditioned on Z. Does this get added to the ob space? Maybe it does. I see. Okay, that's why I have it wrong. Well, that's obnoxious. But, like, fine, I guess. Do we use this? We don't. Why's it gotta be so fancy? Because now I have to pass this in, don't I? Affected 3, got 2. What is wrong with this? Oh, I see it. And then the discriminator doesn't condition on Z, right? No, it just conditions on the state, so we do on hidden. New algo. Freaking driving me nuts, all these things. I'll tell you. Ugh. Takes 2 positional arguments. I don't think you don't need Z at all here, do you? No, you don't. You just need 4, 6, 2. Yeah, this just takes hidden. And then you have to pass, though, to train. How'd this get past this? Yeah, you need the, where's this thing? And this needs to get this one. Then you get Z indices and Z. This loss is still like 0. Okay, let me try sanity on this. Now it shouldn't be able to now it shouldn't be able to predict. Hello, fighting, yes, fighting algorithms. Okay, cool. So now this is the sanity. The sanity works here. If you don't give it the conditioning, it can't predict anything. If you do give it the conditioning, it can predict. Now, how do they initialize these values? Where is it? Not this one. Memory. I don't know where these get initialized. The archive. Okay, the reason that they don't have any is because they're making them dynamically, and they're making them a stupid one hot. So that's silly. It's literally a one hot the way they have it. Yeah, the discriminator is just getting instantly optimized. That's weird. Well, almost instantly optimized. And what was the network that they had on this? Yeah, they have a 3-layer net on this. I only have a 2 and I still learn it. Oh, wait, is it? No, hang on. Hidden 1. No, they've got 2 layers. It's fine. It's the same. States, skills, relu. Oh, no, they do have 3 because this is the output. Interesting. Interesting. GPU is fighting for its life as well with whatever the heck this thing is. This should at least do something. I imagine you're not supposed to have 0 loss, like, basically immediately here. I mean, but I checked it and it looked like it was predicting correctly. Is 128 like way too many skills? That should make it harder, not easier, though. Yeah, it's easier. Hmm. Let me think about how this is possibly just like instantly predicting. So you pass, where is it? We're passing in, where's the discriminator? There it is. So we're passing in the hidden state. The hidden state gets Z. Okay. And then from the hidden state, we're trying to repredict Z, I guess, right? That looks like what this is. Q of Z given ST plus 1. Gather Z, yeah, so that's right. And then that's the reward. And then it's just cross entropy to train this thing, right? Mm-hmm. Log softmax. Wait, is this supposed to be log softmax here? That looks weird. Maybe it is, maybe it isn't. Hang on. Discriminator. So you take log softmax for the reward. You do not take log softmax here. So I don't know why I have that. Oh, I don't use it. I don't use it anyways, though. Q and Z indices. You do this loss coefficient times the loss. I mean, this looks totally right to me. Then let's just be sure that this is actually doing what we think. So if we don't add the reward, I don't know how it's this slow either. Holy hell, is that slow? No, that wasn't it. It's just slow. Why? There's something weird with that. Like, it shouldn't be that slow. If that does anything. Holy hell, what is taking this long? Like, that doesn't even make any sense. Okay, so something's still crushing our perf. Yeah, this is not supposed to be anywhere near this slow. Guess it's this one. Oh. So stupid. Okay, so you can see right there this massive freaking difference. Let me use the restroom real quick and then we'll figure out what's wrong with this mess. Okay. Something is like completely crushing perf here. Right? What would it be? Okay, so overhead not in here. Overhead's in here. Why would this policy be so slow? Is this cross entropy really that slow? Oh, hold on. I know. Do I know? Let me see. No, I don't know. Thought I knew. Hmm. It's just telling me that this subnet is very slow. It's like cross entropy is not a particularly slow loss to compute for a small number of classes, is it? I didn't think it was. Something else wrong here? No, I mean, if you let it run, does it still train? So taking the reward bonus off. Oh, it is still stuck. I think I must have broke something else. There's no way that learn should take this long. And it still doesn't work. Okay. Where's this thing? Maybe this has to be marked as, thought that would be it. Maybe not. To this thing? Something is just like really screwed up here. Now, this is still slow. This cannot still possibly be slow. There's nothing freaking running that's different. There's literally nothing running that's different. It's in the learning loop too, is the weird thing, right? Yeah, the overhead's in learn. It's a tiny little policy. Unless it's like doing something weird with it twice. I mean, this is insane, right? Like, how the hell is it slower? Unusable. Torch. Nope, not here. Not here either. I have everything freaking commented. I'm gonna go nuts. just make the fucking train step 10 times slower for no reason day, apparently. I'm not even doing anything that should change this. I'm like baffled as to what the hell this could be. Not compile screwing with us. Nope. This is cursed. This is fucking cursed. What the hell? It's just, I don't know what's happening here. This should be the same as the original. The only thing I can tell is this extra network exists. And learning is just way slower for no apparent reason. Literally not even using it in training at all. I'm gonna figure out what this is. If it's something stupid, I'm gonna be really mad. Wasting my freaking Saturdays on bullshit. Okay, it doesn't even have the freaking loss in here anymore. Like, doesn't even have the network to have the loss. Right? You gotta be kidding me. Torch is so fucking stupid that it will just broadcast that tensor and make like some insane gigantic value loss. That's insane. Okay, yeah, I'm mad. Fuck you, PyTorch. Ridiculous. Just broadcast to a gigantic value loss. It's like, oh yeah, that's fine. Ugh. Stupid. Now we know why it wasn't freaking doing anything. At least it's not something wrong with the method, but I'm mad about that one. It's more reasonable, right? For the losses. So not optimizing the loss. Maybe they don't do dot product. Maybe they can cat. Yeah, they can cat. Okay. We'll try that. size this. There we go. I don't see how this is going to break learning completely. That seems very weird. I mean, nuts. See, I don't understand how on earth this could break anything. This is the problem. I don't understand how this can break anything. I don't understand how the, like, concatenating some random thing can possibly screw up learning to this extent. This is obscene. Like, look at this. Immediately learns, right? You put this garbage on and nothing works. What? This is stupid. Am I fucking stupid? Code's just a mess. Fine. Whatever. There. I'm just getting irritated. I've been doing this shit all day. Okay. Now maybe we can get somewhere. It should still work with random noise added. Don't you dare. Okay. It takes a little longer to ignore the random noise. Does it work? You gotta be kidding me. You concatenate a little random noise and it's just broken? This works immediately. Now it magically works. Or are we still stuck? We're still gonna be stuck, huh? I'm going to go insane. You add a bit of noise and it totally screws you up. Are you healed up? Um, I mean, not remotely compared to how fit I was before I was sick. Um, I mean, it's gonna literally take. I mean, if I were like actively just like trying, like if it were like my main focus to get back into that shape, it would be 6 months of hard training. It's probably gonna take me a year with all the work I've been doing lately. I mean, it's Saturday. I got up at 8. I've been working since 8, and I'll probably be working more in the evening, depending. And I'm usually fine with that, though today I'm just mad. Because today I've been working all day and haven't gotten jack shit done. Because these algorithms are fiddly and they kind of just suck. Making good progress today? I wish, but not really. I mean, the thing that's really going on here is just like we're doing this research a little bit early. Um, there are like core fundamentals that I should be addressing before this in RL, where things are just like utterly stupid and nobody's bothered to fix them for 20 years. And it's like, it's almost to the point where it's a miracle that anything in RL has gotten done at all, because the state of the field is so bad that you basically have to burn PhD students 20s in order to get the smallest bit of work done. Um, and that is fixable. That is a fixable problem, but it requires a very, very different approach than what I'm currently doing here. But at the same time, it's like, yeah, I kind of have to try out existing methods and stuff on Puffer because people want these for their problems that they're throwing stuff on right now. It's kind of maddening. I mean, literally, we're at the point where I have magic hyperparameters where, like, if you train, it works perfectly, but if you concat a little bit of noise to the observations, even if it's like very small amount of noise, it just breaks training. Not add it to the observations, concat it to the observations, still breaks. Crazy. Why the hell do they add this thing? This is insane. Do you have a team? We have open source contributors working on various environments and such. But as for like the algorithm work, it's mainly me. Okay, that's something at least here. Why do they have this term? Like, isn't this term just fundamentally stupid? Well, it's supposed to be negative, but that's not going to help. Now it's just a giant negative term. Okay, I mean, this is at least something. Can you... This plugin's gonna drive me nuts. Stop it. Fucking thing. I wish I could just disable multi-line completes on this thing. Because, like, I never want a stupid AI writing multiple lines of code. It just writes garbage every single time. Okay, finally. Took 5 times as long because of the AI. In my damn way. Cool. This now should work. Okay. Let me try this. Oh yeah, so Brad, if you're still here, I should mention that the core stuff is me, but we do have more people working on puffer adjacent things for companies as contractors. But that's purely for like business side stuff. I mean, not business side stuff in the sense of like admin, but on technical stuff for clients. The core dev on Puffer is me. All right. What kind of things are businesses using RL for? Got NDAs on that at the moment, but I can say it's like it's various stuff. It's like some of it's industry RL research, some of it is in like robotics control type stuff, and then there's new stuff that's finance adjacent. It's just like we don't really have a specific RL area as much as we do general purpose RL tech for people who need like simple RL thrown onto their problem very fast and with some of the stuff that we use as well. We've got things like good hyperparam sweeps, which are very nice for solving new problems without taking forever. We have like a very fast trainer implementation. We have stuff so it's relatively easy to add stuff into it. As frustrating as this is right here today, this would be like a frustrating month in a different RL library instead of a frustrating day. I wish RL was focused on more than the current LLM paradigm. Yeah, I mean, so do I, but it's fine. There's still plenty of applications. There's still companies doing it. It's enough for us to be able to keep this going. Are you self-funding all of this? Well, yeah, it's a company though, so it's bootstrapped. We have revenue. We don't have as much revenue as I'd be making in industry, but we do have revenue. I mean, I've been doing this less than a year, and except for like big hardware purchases, like it's well on its way to being profitable. Depends how you measure. I didn't even like consider going for VC because it's just gonna add strings attached that I don't want to deal with. Do you see RL surpassing every other form of learning? No. I think it's going to be used in conjunction with other forms of learning. Hey Will, how's it going? We've been fighting bullshit algorithms all day. But at least we have this is now going to be the old like Sergey's diversity is all you need algorithm. Long time. Yeah, what have you been doing? Have you just been in LLM land working on L, or like what have you been up to? Sick to see the progress. Yeah, we've got training up to a max of 2.5 million steps per second, depending on the config. And we have really, really good hyperparameter sweep stuff. And we're making some progress on the new algorithm. It's very difficult, a lot of math, but we're making progress. I think that this works. Cool. So this will run, hopefully not break. We will see whether this actually learns anything reasonable. It's not a great environment for it, to be fair, but we'll see. Working on computer, using agents now. More like VPT large scale. Computer using agents now. More like VPT. Oh yeah, I know a guy who was wanting to do that, but yeah, that makes sense. Cool. I'm sure you have fun compute budget stuff to deal with. With some deep mind. Are you at reflection? No, they're doing code agents, I think, right? That's the other deep mind guys. Stealthish general agents. That sounds like generally intelligent. That means you have about 1 year before you're gonna rebrand. Oh yeah. We have 22,000 experiments in here so far. Mostly just from me running stuff on one node as well. That's fun as fuck. That's cool. The RL stuff is fun, except when I'm dealing with like the previous RL lit. Like everything in Puffer is fun, and then as soon as I have to go outside of Puffer to like some existing thing in RL, it's just god awful. But I guess that shows you kind of what progress we've made with Puffer, right? Need to get back to Puffer, yeah. I mean, it's like the neural MMO 3 stuff is going to be, whoops. I honestly think that this is going to be such a good environment as soon as we have, some stuff running a little bit more stable. I mean, this is like the small version that we did for web, right? And you can just see all the agents running around, dynamic economy, items, levels, like all sorts of stuff, skills to train. So we have environments, we have fast training, we have hyperparameter sweeps. We just need a few last things before we can really start scaling stuff. But the algorithm side stuff is tricky. Speaking of which, the current project, this was just like a quick side thing for a client, but the current project, I'm attempting to replace generalized advantage estimation. Who did the art for neural MMO? Are they credited? I probably should, even though it's just a purchased license. But it is credited in the repo. With what? It's a learnable version of JE that doesn't require stupid lambda or gamma parameter. It's this. You buy a license per project. They're pretty nice. Require a lot of pre-processing. Well, the current thing, Will, is where's this? Do I have it here? I've been fiddling with different versions of this. It's a variational value function that predicts a whole bunch of steps ahead. Paper link? There's no paper link. You're one-shotting the multi-agent team. They couldn't get out of their own way. Dude, I'm really, really trying. And to be fair, one of my favorite things that I'm a little bit annoyed that I didn't end up there full time. But the one thing that I will say that I find very funny is the project that they did right after that I left, was the what was it? Hide and seek. Yeah, the hide and seek stuff. Um, the main thing that they were interested in were the transfer results on that. I told them it wasn't going to work. I told them exactly the reason it wasn't going to work. And lo and behold, if you look at the appendix, all those experiments just went into the appendix as, they kind of don't work. So, unfortunately, it took me an extra like 5 years to get the engineering experience to do everything like really, really well now. But I think we're in a good spot to do this now. The thing is that like, in order to really make all this stuff work and work well, I just needed to have the engineering experience to know how to build stuff 1000x faster than they were doing it, which I now do. So now we can actually have everything run, like we're training 2.5 million steps per second at the most, and 1 million at least on average. So if you look at like CleanRL and SP3, usually training speed is between 1 and 10,000 steps per second. So we're between 100 and 1,000 times faster. So that means I can now actually run all the experiments I want to and have a really, really quick feedback loop for dev. And, I can full train breakout in about a minute and a half. So, I actually don't have to be, like, I don't have to be running stuff on something as trivial as like a 5-step grid problem. I can just do stuff on like breakout or Pong or whatever, and it runs in like a minute, and then I can run stuff on, our harder M's and have that take like an hour, right? That's been like the really big thing. But now it's going to be a matter of using that to improve the algorithms. This thing is driving me nuts. Yo, I think I have the sim rendering work. Want to take a look on Discord? Absolutely. Let's just.
Hey, what's up?
Hey, Spencer.
All right, let me just share a screen real quick.
Yep. It has been a crazy, crazy day of like algorithm hell. But
Oh yeah,
I'd like to help you on this end. It's just been ridiculous. I got one
I
thing
uh,
implemented at least.
I think I got pretty good.
I'd say.
If I can just share my screen and not have my MacBook break in half.
Mm-hmm.
All right, do you see?
Man, good job. Holy.
Yeah, so there's no real like so this is stepping through all the time steps as you can see, but all of those are just preloaded into memory. So
Yep.
there's like step isn't really doing anything
That's
besides
fine.
incrementing. It's just incrementing time step by one.
Dude, this is
So
awesome.
obviously it's at like 6 million plus steps per second. But I mean, even if you just added an action in there of just random actions, you'd still be there. So I mean, that's just kind of
Okay.
where.
Dude, this is sweet.
I mean, I don't know for sure if like the lines are actually all correct or like where the
I mean, they
you
look
know.
good.
But I mean, I think that's correct. I mean, I just haven't actually checked what the original one is supposed to
Dang.
be. I was gonna send a video over to the team on Slack and let them and ask them
Yeah.
if they had any if it was screwed up at all.
I mean, I think at this point you just like so this is like the naive one where it has to if you have to compute observations, you have to loop over everything, right?
I have no observations in here yet.
Yeah, but if
So
you
that
were to
was,
do it, like the
yeah, yeah,
simple,
yeah.
you'd have to loop over everything, right?
Correct. I just
Okay.
loop over everything.
Just do that, get the agent step thing to work, and see how fast training is. Just like out of the box. Because it would be hilarious if the completely unoptimized version's already faster.
Yeah, I mean,
This is
this
GPU
also
driven
has no
or CPU
what's
driven.
it called? Like no segment what is it called? Polyline decimation algorithm. It just has all like 10,000 dots on here and segments.
We
They
don't
don't.
we don't care. We'll optimize at, like the point is I want to just get the naive thing first,
Yeah.
and yeah, and then we can go from there. And like specifically the fact that if you keep it naive and you keep the code lot like the code small enough, it's going to be easier for me to help you actually come up with the data structures that we're going to want.
Yeah, I mean, this is all using the entity struct. So this is all
Yeah, that's
I
what
put
we
it all
want.
into the entity array,
Great.
and the most annoying part was really just like getting the JSON file to actually go to the right
Yep.
stuff.
Can
But
you
the whole
load
thing
like
I think
different
is
scenes
still like
in?
a few hundred. Yeah, I've used multiple scenes, so I can load in a different scene.
Sweet. Okay. So
Um,
yeah, I think
give me
just like get the train loop working at this point with like the
yeah,
simplest possible thing, and then we
sure.
can just be like, hey, this is so early, but already I like the thing is they train so slow that even with zero optimizations, like if you use the multi-processing backend, you're probably just gonna win.
I'm pretty confident I'm going to get to a million on this one. I mean,
With
we'll see.
no, you're gonna get
I
to a
think, but
million with naive observation looping.
maybe, but
That would be
we'll
something.
see. We'll see. Okay, like just
I
I
think
have to
you're gonna
first
get more
master
like
ob.
50,000, but it's still gonna be faster than
I
me.
mean, I don't have any collision checks going on, right? So if we wanted to go like, do we want to do collisions or just want to get like early training of just saying like, hey,
Initially,
it's
don't bother, and then we'll do it after.
okay,
I
yeah.
just
Because I
want to.
figure we at
I
least
just want to get like here
get actions
are.
going,
Yeah.
like have it train in some capacity,
Yes.
and I'll try and match the observations somewhat.
Yes.
Their observations are a little bit different because they did like the segment type thing, and this is all smaller ones. So
Yes.
I'll figure something out. But I at least think I'll be able to get something, hopefully training by tomorrow. This is my
That's
goal.
sweet. Do you mind if I if I puffer theme the colors?
Yeah, you can fucking puffer theme the colors, dude.
Very good.
I don't give a shit.
It
But
actually the thing is it actually kind of matters because it keeps it's it's puffer branding.
yeah, fair enough. But yeah, I mean, I think the
Oh, you
maps
got
turned
it
out.
scrolling around. You like, oh, look at
Yeah.
that.
Yeah, I have 3D camera movement going on. This was like a little annoying,
How
but
long is
I just
this?
the lines of code.
Yeah.
Nothing, dude. 300 something for the .h file and 200 for the .py file.
Well done. Well done.
So, and I mean, I'm certain there's things that we can change or whatever, but I mean, if it gets to 1 million, then I mean, I don't know, who cares?
Let me just message you one thing because we are on stream, but I'm just gonna message you one thing real quick on the side.
Kind of sick though, right? It looks
Yeah.
all smooth and shit. All right, but that was all. Matt, I was gonna send a screen. I'll send a video recording to the team and give them. Do you want me to send that? Give an update after we do training, or just go ahead and do an update now?
What do you mean give an update?
Like, just go ahead and share a video recording of this to see like if it's at least visually correct with this scene that they have
Sure, if
for
you
this
want
whatever
to.
this thing
Yeah,
is.
if you
Just
want to, you can just be like, "Hey, here's a quick initial thing. Still working on it."
yeah, and then
Yeah,
whenever
up to
we do
you.
training, I'll do another update after us to get a training speed going.
Yeah.
Okie doke. All
I
right.
just DM'd you something as well that you may or may not be interested in.
Let me. Yeah. That sounds pretty tight. I'm here for that.
Yeah. I mean, you've done a great job on all these ends, so. Let
Just
me.
yeah.
Uh.
Let me say something.
Yeah.
But
Yeah. We'll just handle this up, not stream. Yeah. Okay.
that's fine.
Cool.
We'll handle off
I'll
stream.
send you.
But
Yeah, I'll send you details, but it's gonna vary. I don't have like upfront info on that, but yeah, we will chat.
yeah. I'll just
We'll
shoot you. I'll
chat
shoot
off
you a couple
stream.
messages. We'll chat off stream on some
Yeah.
Discord stuff.
Okay.
No worries. But
Cool.
yeah, that's where we're at, and we'll see how it gets training, and
Okay.
maybe we
This
can
is
even just like
sweet.
crush some results, and then
I
did the
wouldn't be
project.
surprised. I mean, this is what
So
I
here,
kind of expect is like they have all this code, but it's like I bet you can just do it faster in a tenth of the code with no engine.
so yeah, no, I mean this is literally nothing in terms of lines of code. I did
Oh.
this afternoon, really pretty much all
Well
day
done.
today.
I
Okay,
don't even know.
other
I don't
thing.
know if I could have done. I don't even know if I could do it that quickly. You've gotten pretty good at these M's.
If we can do something, that'd be super sick to rename it of drift is because like how Japan like modeled their entire city in terms of like point clouds. Like,
Okay.
what if we just like drop like an entire city and then put like 10?
Uh-oh, you're cutting out. But yes, drop entire city into Puffer. That would be hilarious.
Yeah, like just drop entire city, make it GTA Tokyo,
Yeah.
and because all of those road data is already like done by Japan to some degree. I don't know if lane
Yeah.
data is in there, but I mean at least road data. I mean you can kind of
Tokyo
extrapolate
Puff.
where a lane would be just off of with requirements.
Okay. Tokyo Puff.
Tokyo Puff, dude. Tokyo Puff.
That's funny. Okay. Cool.
Anyways, I
Well,
will. I'll hit you
you've been
up.
doing some cool stuff. We will sync on this soon. Let's do that after you get the just initial train loop doing something. I think it should be
Yeah,
it should be pretty easy with what you know now to just get like the agents to go to the goals if there are no collision checks, right?
yeah. I think it
Yeah.
should be fine.
So just
We'll.
if you
I'll
can
see
get
like
that
what
to do
obs
it.
are even. I'm curious to know what obs are even necessary because I feel like the obs are collision prevention than goal necessarily. But
Oh, if you wanted to, you could literally just put like agent position goal.
yeah. That's what I was
Yeah.
thinking. I mean, like,
Just do that for now,
just
and
like
then
super
we'll go from
simple, and
there.
then we'll deal with the other complicated stuff later on. I mean, but yeah, I think that'll be good to start.
What's your philosophy for Ocean M contribution to few super high quality M's or spread the net wide? The individual M's don't have to be like crazy complex as long as they are useful as a training benchmark in one way, but the code does have to be good. We do like to try to keep the code quality high. But the thing is, it's really not that hard if you just look at the way we've written some of the existing ones. It's literally like first year undergrad level C. It's loops, conditionals, and like that's it. So, yeah. Okay. Well, thanks for the quick update and the prototype. Spencer.
Yeah.
I am going to, it's 5:30. I'm gonna spend the next hour trying to figure out if I can get the new algorithm to do something. It's it's a real mess. Like the math's a pain.
All right. I'll peace out later.
So yeah, bye. That was cool. Yeah, that's awesome. I didn't expect him to have it done that quickly. It's a nice prototype. You know, sometimes you don't know if it's going to be 300 lines or 600 lines without like doing it yourself. So yeah, I wasn't sure, but that's cool. Okay, we'll let this run, and then we will go back to P3O math. So since there are some folks who were not here for this morning, this is an attempt at replacing generalized advantage estimation, which, for context, this is kind of misleading that this only has 4,300 citations, because the PPO paper is 24,000 citations, and really the core piece of it is this. So this is like, I'd say arguably the most important piece, algorithmic piece in RL, and we're going to try to replace it. That is the goal. And I think it's actually kind of doable. I'm just getting stuck on a little bit of the math. So this piece that is difficult here and specifically, what we are trying to do is we are trying to replace these discount factors of gamma and lambda with just a learnable per time step gamma factor. So instead of having this, you have gamma 0, gamma 1, gamma 2, gamma 3 without the exponent. And the idea is that that should allow you to learn the importance of samples over time without having to just tune a discount factor per environment. There are many reasons to think that this would be better as well, but at least we would like to match JE performance without those additional parameters. Now the thing that I've gotten stuck on here is this gamma has this nice property where it decays down to 0. But the value function that we are using with our gammas don't have that property. Our gammas decay to the standard deviation of the reward, I believe, or to the standard deviation of the return. Let's look at the math I have so far. So I'm replacing gamma with, let's fix this. Okay. 1 over sigma squared. Sigma is the predicted standard deviation of the reward, minus 1 over the true standard deviation of the reward squared. So this is our confidence in the sample, less the base confidence, like if you were to predict randomly, the base confidence. So this is supposed to be how much more confident are you in your prediction than random, or than base. And let me see. And I don't think I see any reason that this doesn't just work. So maybe I just was getting frustrated this morning. Maybe I'm actually way closer. Maybe I'm way closer than I thought to having this working. Because there was another thing that I was trying to do earlier this morning that I don't think made sense, and I kind of just burnt myself out on that. Maybe this is quite simple. Maybe it is. here is, let's just get the formula up by one side, and we'll see where we went wrong. Advantage scale, VSTD, RSTD, right? What do we pass here? RSTD, okay? So it's going to be 1 over VSTD squared minus 1 over RSTD squared. And then these get summed up. Buff of index equals this. Return is equal to hang on. I think I understand. Okay. Yeah, so what's happening here, this is setting this buffer to the discount factor at each time step. And then this is equal to the sum of discount factor over time step. Values mean I. I don't think this is correct. Yeah. So this index is wrong, first of all. And then also this buffer is not is also not being computed correctly. Okay. So I'm seeing the errors that I made this morning, and I think I was just tired. So let's see if we can do better now. Oops. Get this out of the way. Advantages. I think we just do returns. Returns. I think you need bounds. I think you need advantages. Duns, rewards, RSTD. Yes. Okay. Reward block, math, values, mean value, STD. Turns. Duns. I also don't know why I did this. So we do rewards, duns, steps, horizon, BSTD max. Okay. Let's get this signature. Oops. Then this also needs to be matched. So this is reward block, mask, value standard deviation, returns, data pointer, rewards, duns, some steps. Okay. We don't need this anymore either. Reward block, reward mass, values mean, standard deviation, turns. Oops. Dones. Horizon BSTD. And then this one, block mass mean standard deviation returns, rewards, dones, horizon, denotes num steps, B, CD max. Cool. Oops. Values. Okay. Then you return returns. This now becomes returns. And this stays the same. Advantages, not needed. Okay. Advantages. This does not need to be of indices. This. Now you do advantages dot 0. Guns, rewards. Oh, it's returns. Yeah, this is returns, my bad. Doesn't need to be of indices. Returns dot 0. Duns, or was it rewards, duns. And then it is P30 horizon. Okay, so there are your returns. Breakpoint. We'll fix whatever we gotta fix. And then we will adjust the kernel. Buff. So we don't need this at all. Let's now fix this. So the way that this should work, j equals, was it k minus 1, 0, j minus minus. Okay, you get your rewards. I don't even know if we're going to need this reward block, reward mask shenanigans. We'll see. I don't think we do. I don't know. You know what? We might still need it. We might still need that for the value law. Okay, so the next thing, returns of index. Gamma. Gamma less than 0, gamma is 0. Then we do R plus equals gamma times reward, gamma times reward, and returns of index equals R. Okay. And now you do not need any of this. Legal memory, lovely. Oh, I bet it's I wonder if this is it. Annoyingly, if you kill during compile, it breaks. Huh, it actually gets past this now. Perfect. There are your advantages. Back returns. Self returns. Dot reshape. That's fine. And then advantages. It's also fine. Cool. Now for value loss. Returns. Be returns. Probably be best served right here. Okay, returns are always 0 for some dumb reason. J is k minus 1 greater than 0. Still 0, really. Maybe actually. Let me think. What? Oh. That's a problem. Okay. Well, there's an issue here for sure. Yeah, definitely something screwy here. Min. Nope, nothing weird in here. Ah. Do these not get zeroed? No, I do zero the returns. This k minus 2. I think it is k minus 2. Let's see if that fixes it. Still massive returns, huh? Okay. Normal values. Plus. You do get a reward there. Oh. Wait, 1 over. This is quite a big, right? This is a problem. Yeah, this is what it was. Okay, so why does this happen? But this is also not the Oh, no, this is actually right. Okay. So I have the scaling completely off. Did I want gammas to sum to 1? I thought I wouldn't need that anymore. But I guess I hadn't thought of this scaling. Do we norm this? That would seem weird. Maybe not. I could norm it so that gamma's sum to 1 and just see what happens. Whoops, we forgot to close these brackets. Where's gamma? There. Lovely. Try this. Okay. Look at that. Huh? It kind of learned a thing. Hello, where's my breakpoint? That's silly. Returns is still 0. Rewards is all 0. Returns is going to be 0 because rewards is 0. Shouldn't be negative either. Well, there's more work to do on this, but this is at least there's some progress made. I'm going to see whether I do this after dinner or not. Let me see about the ablations in the meantime. Did this get stuck or something? This looks like it got stuck. Oh, lovely. See if this does it. All right. I may or may not be back after dinner. If not, back tomorrow. Yeah. Thanks for watching, folks. A lot of algorithm dev today. Check out puffer.ai for all my stuff. Start the GitHub to help me out. And you can join the Discord to get involved. And follow on X for more.